Hello, I'm Ryan Kinchin with High Desert Math Tutor, and today I want to take a quick moment to talk to you about the difference between point, length, area, and volume. Now, points. A point is simply the location of an object in space. So it's very natural for us to even, in our colloquial sense, point at something that we're interested in bringing your attention to. So I could put a dot right here, and that would be a point, and that could be the location that we want to focus on. So you could talk about points on a whiteboard, points on a map, points in the universe, but points are always signifying the location of some object in space. Next, we have length. Now, length is the shortest distance between 2 points. Now, what's special about math in general is we always take the most basic ideas, tools, concepts, and we like to use these tools to construct everything that follows. So I can give you 2 points. I'll give you a point right here and a point right here. Now, length is the shortest distance between any 2 points. Well, the shortest distance between 2 points would generally be a straight line. But what is a line built with? Well, a line is actually a collection of points. So if you put enough points together, dot, 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 I'll put a few that are a little bit longer. But if you put together a bunch of dots, just like the pixels on a screen, that makes up a line. So a line, which signifies length, is actually constructed using points. Well, next we have area. Now, area is the amount of space inside a flat shape. So I'll say flat or two-dimensional. It's the same thing. A flat, two-dimensional shape or object. So anytime you have a flat object, area would be the concept of describing how much space is inside that object. So let's draw a rectangle over here. For this rectangle, if we want to discuss it, it would help if we actually had some terminology, common terminology. So let's say this left side right here, let's call that the length and give it an abbreviation L. And this bottom side, let's call this side width and give it the name or the abbreviation W. So a rectangle we can discuss using its length and width. Well, if we want to discuss how much space is inside this shape, the question is, how would we describe that? Well, what we can do, as mentioned before, we can make use of the previous concept, which is length. And if we want to fill in this rectangle, we can first draw the length of the rectangle, scoot over slightly, then draw that length again. Scoot over slightly, draw that length again, and we can continue to draw this length, repeat the length of the rectangle until we ultimately cover the width. So you may ask, how many times do I need to repeat the length? So the amount of space inside the shape, you can find that by repeating the length however many times it takes to cover the width of the shape. Hence, we have area is length times width. Now, the final concept that we are discussing today is volume. And similar to area, volume is the amount of space inside. This time, it's a three-dimensional shape or object. So what we can do, let's momentarily focus on a rectangular box. So this rectangular box is going to have the front sides that we can actually see. And for context of the interior, let's actually draw the back side, which we cannot see from this perspective. Whoops. Hence, whenever you see dashed lines in math, those represent the edges on the opposite side of the shape that you cannot actually see from this perspective. So this is a rectangular prism, and so we have similar context. Let's call this side of the prism the length. Oops, let me get that. We're going to call this side length and abbreviate it with L. We're going to call this side width and abbreviate it with a W. And for this final side, we're going to call this up and down direction height and abbreviate that with an H. So as the pattern continues, what we'll do is we're going to use area to help us construct this idea, to find and measure volume. So the amount of space inside a 3D shape or object, in this case a rectangular prism. For a rectangular prism, the top of the shape and the bottom of the shape have exactly the same dimensions and shape overall. So one approach we can take here to fill in this space, imagine we're pouring water into the space. So the first portion of this whole object that's going to fill up with water would be the bottom or the base. So this whole space right here is going to slowly fill up with water. Now, you may notice in us constructing a formula for volume to understand it, we can start by covering the area of the bottom of the shape. But what's next? So initially, we've only covered this bottom portion, that level of the whole shape. Well, if we continue to pour more water in, we're going to ultimately start to fill up a higher level of this whole shape. But notice, that's simply repeating the area, but the level has moved up a little bit. Well, if we want to continue to fill in this shape with water, we're going to fill in the next level on top with more water, so we move up another level. So essentially what we're doing as we fill in this shape with water is we repeat the area again and again and again, however many times it takes to actually cover the height of the shape. So for volume, we can say, volume is area of the base times the height of the shape. But the last point I want to discuss to tie everything together is this area for this rectangular prism, that follows the same area formula for a rectangle. So whenever we see A for area in this context, we can replace A with length times width, and here we can bring down our height. So just doing a quick recap, a point is a location in space. A length is the shortest distance between 2 points. Area describes the amount of space inside a flat 2D shape or object, and volume describes the amount of space inside a 3-dimensional shape or object. So I know that's fast, but I hope you understand that I just wanted you to understand conceptually the differences between point, length, area, and volume. So there will be more videos where we get into the greater depth of computing these different quantities within geometry as a whole. Thank you.